So the question we have here is limit as x approaches -3 of sine x plus 3 over x squared plus 8x plus 15. So the first thing I'm going to do with this problem is figure out what value my function equals to when I sub in as x is -3. So I'm just going to do that over here. So the top is just going to be x of -3 plus 3, and then the bottom is going to be -3 squared plus 8 -3 plus 15, which if you simplify this, you'll find that of course the top is 0, and the denominator is also 0 because 9 plus 15 is 24, and 24 minus 24 is also 0, so the function ends up becoming undefined. So in order to solve for the limit or figure out what value y approaches as x approaches but does not equal to -3, we will need to use limit laws. So the two limit laws we need to keep in mind as we're going forward with this question is the product law and the trigonometric law. Now the first thing I'm going to do is I'm going to factor out this limit, and specifically I'm going to factor out the denominator such that my two linear factors will be x plus 3 and x plus 5. And we know this is true because 3 times 5 is 15 and 3 plus 5 is 8. Now what I'm going to do is I'm going to separate my limit into two distinct functions. So sine of x plus 3 multiplied by limit as x approaches -3 of 1 over x plus 5. So why is this true? Well, because of the product law. The product law defines the fact that if limit x approaches a value f of x multiplied by g of x, this is equal or equivalent to saying limit as x approaches a of f of x multiplied by limit as x approaches a of g of x. So since f of x and g of x, if I bring these together, I get the same value over here. I know this property holds, and thus I can employ it in this use. Now, the second thing that I need to do here is figure out what value this limit is equal to. Now, I can clearly see that if I plug in x as -3, I'm going to get 0 over 0. So I need to use trigonometric limit law to ensure that my limit does not go to 0 or become undefined. And the law that I'm going to be using is limit as x approaches 0 of sine of x over x. Now, how can I use this, you say? Well, according to the law, we need to have x approach 0 whilst my two inputs, x over x, need to be the same value. If I substitute u as x plus 3, I can see that when I sub in -3, my u will go towards 0. So I'm going to be plugging in u as 0, knowing that -3 plus 3 will also go towards 0. So therefore, limit as u approaches 0 is equivalent to sine u over u multiplied by, don't forget the side, x approaches -3 over 1x plus 5. Now this will be equaling to 1 because of the trigonometric law defined here. And of course, if I sub in x as -3, I get -3 plus 5, which is equal to 1/2. So to summarize what I've done here is I've used trigonometric laws and of course a product law to figure out what the limit of this function over here is. And what I did first was I broke apart the function into two different distinct functions, where I then substituted u as x plus 3 so that u could approach 0 as long as sine u is over u. And this, according to the second trigonometric law described here, is equal to 1. And then I plugged in -3 as x, and I was lucky enough to get a definite number of 1/2. So my limit here is equivalent to half.